Now we're going to figure out if you got this. I want you to create your own problem. Create your own trinomial that factors. Do this on your foldable. Don't do it on your whiteboard yet. Sorry, my bad. Figure this out on your foldable. So I want you to create your own trinomial that is factorable, that you can actually factor. You can't just pick random numbers. Remember, it's got to meet those two criteria. Add to give you C, multiply to give you C, add to give you B. Create your own trinomial. Once you have created that, once you have your answer, you need to factor it and get your answer. Once you have done that, I want you to put your trinomial on your whiteboard. And then I want you to give your whiteboard to somebody else in your group and have them factor your problem. Everybody understand what the directions are? Create your own trinomial, get your answer, factor it, write that trinomial on the whiteboard, trade it with somebody in your group, and have them come up with the answer, and then you need to check their answer and see if they did it correctly.
I think when you teach things like factoring and rules of exponents, it's very easy just to say, all right, for factoring we need two numbers to multiply to get C and add to get B, and you create the factors and you move on and you call it a day. It's important to understand the whole idea of what a factor is. So understanding, factors of just a number. And so factors of 8 are 1 and 8, 2 and 4, and, what are factors? Because I think kids a lot of times understand what factors are, but they don't really understand when it comes to doing it with something abstract like a trinomial. And so they're factoring it in these two binomials, these two sets of parentheses, and trying to relate that to the fact that if you multiply these two binomials together, you get what you started with. And so something that's very important, and I might have talked about it in the lesson, is once you get those answers, if a simple way to understand, but to also check yourself, is to take those two binomials and multiply them back out. So that way you can see how taking those two factors and multiplying them produces the trinomial that you started with. So being able to work forwards and backwards. And we do, I gave them a little extra practice, which I really liked. It was a worksheet, and it had 3 different columns. They would give you the two binomials, or they would give you the middle column, or they would give you the trinomial, and you would have to figure out the other two. So I feel as though that was a good way to reinforce the whole idea of being able to work forwards and backwards and understanding the combining like terms and even how factoring works. It's also a good opportunity to move into factoring by grouping if you want to. So just trying to reinforce that idea. Students understand area is length times width, and so they're able to work from a length and a width to produce the area. But when they're just doing basic area of just a shape and they multiply the two numbers to get the area, I don't really think, at least at the high school level at this point, you work backwards to talk about how the length and the width are factors of the area. So when we move into trinomials, really getting them to understand that the length and width are in fact factors of the area. So that way if you're given a trinomial that represents the area and you're asked for the length and the width, it's just a fancy way of asking for you to factor it. And understanding that whole relationship of working forwards and backwards. And I didn't get to it, but it would have been nice to be able to do a problem where they give the area as a trinomial and the length, and then they're asked to find the width. And so then that gets into the whole idea of dividing and making that relationship to multiplying and factoring.
What you got?
13.
Oh, sorry, good.
X squared minus X.
X squared minus X minus 6. So, listen up. What does this factor into? Zoe, you still working on it? Okay, what you got? Did you do this one? Did you get the answer? She got it right? Yes?
Oh, you got the answer?
Yeah, Zoe, give me the answer.
X minus 3 and X plus 2.
Okay. Is negative 3 times 2 negative 6, everybody? Yes. Is negative 3 plus 2 what? Negative 1. So that works out. Good. How did you do this? Tell me how you created your problem. There are multiple ways to do this. How did you create your trinomial? What'd you do? What you got?
I just got a big number and I divided it, found the greatest common factors and I put it in and I kind of added them to get my B number.
Okay.
And that's how I got my other factors.
So
that's how I just did it.
Tell me what's the big number you used?
123.
So you did 123, and what did you do with 123? I need everybody listening.
Divided it by 3.
Okay, and when you divided it by 3, what'd you get?
41.
41. So then what did you do with the 3 and 41?
I added them together and tried to get a negative number.
And tried to get a negative number?
Yeah, so I just put a negative.
I haven't figured a problem out yet.
I put a negative 41.
Listen up, please. So when you made 41 negative, what'd you get when you added them?
Oh, when I added them, I got negative 3.
Negative 30 what?
Negative 38.
And when you multiplied them, what did you get?
Negative 123.
Uh-huh. So what was your factor? What was your trinomial then?
X squared minus 38 minus 123.
You need to give me one thing. What other thing do you need to give me? The x. That's one way of doing it. Figure out that number. Figure out factors that multiply to give you that number. Figure out what adds to give you b. And it's just basically kind of guessing and checking. Did anybody do anything different other than the guessing and checking type deal? What do you mean you did the box?
Right. You know how you said earlier?
Uh-huh.
You basically do it backwards.
So tell me what you did.
I had X plus 2
Uh-huh.
and X subtracted 8.
Okay.
And I do the box.
So you did the box. And you got...
X squared negative 8X 3X.
Uh-huh. Uh-huh. Okay. So what's your answer?
So X squared negative 5X.
And so this is what you use? So that's how we did it. Instead of starting with this and trying to create the factors, he said, all right, I can create this however I want to. So I'm just going to make up whatever 2 factors I feel like. He picked x plus 3 and x minus 8. He put them in the box, multiplied them, and said, all right, here's my trinomial. That's one way of doing it, absolutely. Work forwards or backwards.
I think it's really easy when you're teaching and you ask somebody for how they did something and they give you their method and you get the answer's correct, and you just move on. And so students might not understand what they did, especially if it's different than maybe the method that I taught it at the board. So I really like when I get students to tell me their method or how they did something, to have other students to tell me why they did what they did. Can you tell me why your classmate did the guess and check or whatever, and have them, it's the whole idea of revoicing what someone else is doing, especially on warm-ups. I didn't do it for this particular lesson, but a lot of times I have students come to the board and explain the warm-up problems, and then if their method is different, then have another student in the class to explain to everybody else, can you tell me what they were thinking while they were doing it? So just getting the other classmates involved in explaining somebody's response.